Namaskar and welcome back. I am Manojaba and today's topic is scalars and vectors. So, scalars and vectors are one of the most essential topics if you are preparing for your grade 9 onwards. And why? Because it lays foundation for your motion and forces, the entire unit of that. Okay, so scalar quantity is any physical quantity that can be expressed by a numerical value and a unit. So let me give you some examples of scalar quantities. Firstly, mass. So suppose you went to a supermarket and there you take 2 kgs of rice. Why do you check that 2 kgs quantity? Because when you are going to buy something, or in general cases if you have some requirement, you need exactly that quantity, not any 10 kgs or 15 kgs, right? So this becomes important. Scalar quantity is any quantity that has a certain numerical value and it comes with a unit. Now you can also consider distance. You travel from your home to school and that is say around 5 to 6 kilometers. Again 5 kilometers, 5 is the numerical value and kilometer is its unit. Temperature. Have you ever heard that the temperature is 35 degrees north? No, you will never hear that because scalar quantities do not need any direction. You only need one unit and a numerical value. Got it? I hope this concept is clear to you guys. Now let's move on to the vector quantities. Vector quantity is any quantity which comes with magnitude as well as direction. So magnitude is the size or the quantity, but in addition vector quantities also have the direction. That is, they need both of these to express themselves. Examples of vector quantities are velocity, displacement, acceleration, force. All of these are vector quantities. Vector quantities are represented usually by an English letter, and on top of that you will see there is an arrow pointing. So this is how you can understand this is a vector quantity. Firstly, scalars and vectors are the physical quantities. Physical quantities are what? Physical quantity is any quantity which can be expressed in a numerical value, which can be measured and expressed by a numerical value and a unit. Now let's quickly see the difference between scalar and vector quantities. So here we have a comparison table. Starting with definition of a scalar quantity, scalar quantities have magnitude, that is size only, whereas vector quantities have both magnitude, that is size, and direction. What it includes? Scalar quantities include only a number with a unit. For example, 5 meter, 10 kg, 5 second, etc. Whereas vector includes a number with a unit and a direction. For example, 5 meter east, 10 towards north. Third is the direction. Scalar quantities do not need any direction to express them, whereas vector quantities has a specific direction. Scalars are added using ordinary algebra. For example, 5 meter plus 3 meter is equal to 8 meter. So it following the simple ordinary algebra rule. Whereas vector quantities are added using vector addition, that is head to tail method, and resultant has both magnitude and direction. Now the example of scalar quantities: distance, speed, time, mass, temperature, energy, volume, area, work, density, etc. All of these are scalar quantities. While vector quantities, few examples are displacement, velocity, acceleration, force, momentum, weight, electric field, magnetic field, etc. Now let's talk about some real life examples. The distance from your home to school is suppose 2 kilometers, which needs absolutely no direction. Whereas you walk 2 kilometers towards north. This is distance plus direction. Now how you represent it? It's representation. Usually scalars are written as normal numbers, example 25 meter, whereas vector are written in bold letters or with an arrow above them. So you can see the example F and V for force and velocity with arrows on top of them. In short, scalar is size only and vector is size plus direction. So I hope these concepts are very clear to you now. Now let's understand vector addition in the simplest way. Vector addition means combining two or more vectors to find one single vector called the resultant vector. Imagine you walk 5 meters towards the east and then 3 meters towards the north. Instead of describing these as two separate movements, we can combine them into one final movement from your starting point to your ending point. That final movement is called the resultant vector. To add vectors, we use the head to tail method. So firstly, you have to draw the first vector as an arrow, then place the tail of the second vector at the head of the first vector. So finally, you can draw a new arrow from the start of the first vector to the end of the second vector. This new arrow is the resultant vector. So remember, vector addition combines both magnitude and direction to give an overall vector.